Hello everyone, in this video I will be explaining you my code base which was written in Python. The main file, as you can see, this is the folder structure which has a database, enhance, and the main application file which is called app.py. The database folder contains all the fingerprints samples which I have collected so far. Those are used for matching fingerprints. Enhance is all the utility functions which have been written down, and the app.py is the main Python file which is used for execution. This Python file is internally using the other enhanced all the utility functions. So let's start with this. Initially I have imported OpenCV, which is import CV2. I have also taken operating system, numpy. Continuing with all the other imports, we have matplot. We also take the utility function image enhance. Also import skeletonize, which is another Python library which is available. So the execution of this code is expecting two imports, which is two image files name, which is used to compare two images. So let's see. In the main function, as soon as the control goes to the main function, first thing is it will try to gather the input which has been provided as an image name, and then find it. Like OpenCV will be used to read the image from that particular location with that file name. Then we use get descriptor function, which is been written above. Which this function usually do is it will take the clash from OpenCV based on some particular limits. Based on that, once we get the image, we'll apply to that image function the output of that function, and apply method which is also available in OpenCV. Inside that we'll use that image. So these is getting the descriptors or getting the reference points from the image. Once we get that reference point from the image, we'll store it into an image value. Once that image is stored, we'll use image enhance, which is the image enhance function located in the utility function. So what this image enhancer function, what it does is it finds out all the edges, all the segments, all and inside our fingerprint image, and enhances it so that it will be easy for us to compare both the sets of fingerprints. So in the rich segment function, we'll pass the image, we'll also pass the block size and the threshold limit, so that it will give us an output of a normalized and the masked image. Moving along, passing all the segments and block size, image, orientation, smoothness. In this what we do is we pass in the fingerprint image, which is then oriented. We pass in the normalized image, and from the previous function we check the orientation of the fingerprint, also provide the block size and the smoothness, so that it will give you the proper oriented image, so that the proper comparison of two fingerprints can happen. Once this goes through this, the output of this is later on forwarded to another utility function called rich frequency. What it does is it estimates. It is used to finalize all the ridges frequency in the image, which takes input image, also take the orientation, window sizing, maximum and minimum length of the orientation, and then it returns back an image size of a particular image. So once we get this, we move to a different function called rich filter. Rich filter is used to enhance the orientation of the image. It takes image orientation scale factor for x, scale factor of y as input, and returns back the filtered version of the ridges. Going back, so this is what image enhance does. It gives you the image back as the return object. Once we get the image back, we pass it along and get all the threshold values for the image. uh, which is the outer bounds of the image and the inner bound. Once we get the image of that, we create into a range of 0 to 1 to normalize the whole image set. Skeletonize is used to get all the bare bone of the image so that we can pass it into using numpy.array function and get all the vector sets of that particular image. After we get the vector set of that image, we pass it into the remove dot. So remove dot is a function which takes input array, which is the inner thin. This input array is then split into various arrays of some dimensions. So we get T0, T1, T2, and T3. These are all the numpy arrays from the range of different ranges. This numpy array is then saved into enhanced image section, image as a variable. Then we pass all the numpy has a function called zeros, which takes an array and convert all the values from that array, from this particular range, in this case 10, 10, to all zeros, and that has been stored as in the variable called s0. Once we get all this information, we pass the initial array t0 and and apply a shape function with a range of 2. This this gives us the width and the height of a particular image. Once we get the width and the height, we parse that width and height to get all the computation which we need. And once we get all this computation, we are trying to get all the points which are specifically ridges or ridges in our fingerprint image. This is what it does, and returns the T2 value, which is an array, back to us. Moving along, so this operation is done in both the set of image which we provide, and once we get this array back, which is all removing all the dots and all the ridges from the image, we pass this image which we have initially worked on in like a couple of steps back to the OpenCV corner Harris function, which takes image and the dimensions of the image along with the threshold factor. Once we get this, we in return we get Harris corners as a variable. We store that value and pass it into normalize function from OpenCV to get all the min and max of that particular. This is OpenCV's algorithm to get all the vector points of that particular image, compare it, get all the corner cases, edges, reaches, and save it into the system, into the variable. Once this variable is there, we create the normalized version of the image. This normalized image is saved into Harris normalized variable. This Harris normalized variable then apply the shape object. Once we get this shape object, we run our for loop against that shape range and get all the key points which are required to match. This key point is all the vector coordinates gathered out of our computation on that image, and which is stored in this key point, which is later computed on using the orb underscore create. Once we get this orb underscore create variable, we do all the computation on the image and the key points which are gathered from our calculations. This whole process is again applied on the second image to gather all the vectors from that particular image as well. Later we run the BF matcher, which is another OpenCV function which is used to match all the normalized values which we have got. We sort through these values, run it against, and then see whether the values are matching or not. The matching values are later in VC we generate a draw point of the image 1 and image 2 and put it as an output for our system. So output of our system is AR array 0.image4, which is just the drop points of both the images. Similarly, we get the drop points of image number 5 and then we show it. That is our first output. Second output is once we get all this keys and all the array values, we try to draw matches on the particular images, and then we plot it and show it to the user to see we are getting a match. So the response is generated based on the match score. The minimum threshold is 33, which is the lowest matching score. If the fingerprint does not even have matching score of 33, it will say the fingerprint does not match. Thank you.